for today's session. This is the first session on the new platform, so we're hoping we don't have any teething problems today. You can, of course, submit questions using the Q&A panel you should be able to see on your webinar screen. And also you can access the materials from today's webinar from the download at the bottom right-hand side of the webinar console where it says Files. We're also going to make those materials available on SlideShare shortly after the webinar. We'll send out a link to the attendees from today's session, which includes that. Okay, so let's get started. The topic for today's webinar is disaster recovery. This is one of our Journey Through the Cloud series webinars. And as you probably know, the Journey Through the Cloud series webinars, these are an intermediate series of webinars intended to take a solution-orientated look at AWS services and explain to you how you might be able to use those AWS services to solve particular business challenges. So we're looking really at common use cases, stepping stones that you can use to move into the AWS Cloud, learning from what other customers have done, and also trying to share some best practices with you that can help you bootstrap your projects. We do have another series of webinars called the Masterclass, and in the Masterclass series, we tend to dive deep on particular AWS services. We've got one of those coming up in a couple of weeks, which will look at DynamoDB, so you should get a mailer about that, and if you're interested, of course, sign up and follow that Masterclass series of webinars too. This is Journey Through the Cloud, and we're looking at disaster recovery today. Now, DR, or disaster recovery, it's a very popular use case for AWS services. And one of the main reasons for that is because it gives you an opportunity to learn and explore using AWS in a non-production use case. So it's a little similar to running development and test workloads on AWS in that respect. You also have the opportunity to phase systems that you might have in your DNR environment into live as part of your invocation tests. So you can gain experience with putting applications into production on AWS in the DR context, which is also a great framework to use for learning about AWS, of course. Of course, you can also benefit from lower costs, and the pay-as-you-go model for AWS services can help you with that. And we'll talk about some examples of that later on in this morning's session. You also gain the ability to test DR procedures more frequently because you can create multiple DR environments. You can destroy DR environments that are no longer required if tests fail without having to repurpose them. So you gain that ability to wrap that DR invocation in a set of automation tools which can help you test it more frequently. And also this last one's an edge case, but it's quite important, and that is because you have elastic environments with AWS, and you can have multiple of them. If for any reason you need to invoke DR while you're in the middle of a test, which is uncommon but does happen from time to time, it's possible to do this in a much more responsive way if your DR environment is built in the cloud, built in the AWS cloud, than it might be if you had to clean up that environment before you can start a real, in quotes, DR invocation. So just bear in mind the parallelization, the multi-environment nature of AWS and the way in which that can apply to your DR. So what's the agenda for today? We're going to take a look at why you could and should use AWS for disaster recovery. We're going to look at some AWS services that are relevant to this particular solutions area. We're going to have a look at a few common architectures for DR on AWS, focusing on two in particular. We're going to look at a few customer case studies and go into one example in detail of a customer actually here in the UK that uses AWS for disaster recovery services. And then as usual at the end of this webinar, we're going to point you to some resources that you can use, access, in order to learn more in your own time if you're interested in doing so. So why AWS for disaster recovery? First thing to say is this is a very common use case for AWS by customers. So the first part of that question is answered by the fact that a lot of customers are already doing it. We have obviously a very large base of case studies that you can access on the AWS website if you follow the URL at the bottom of this slide. But just to focus on these four examples very quickly. SunPower, they're a solar power company located in the US who also do equipment leasing, so you can lease solar power systems from SunPower. They're a relatively new business. They got some really good business benefits from deploying both their production and DR environments on AWS. And if you take a look at their case study, which you can find again using the link at the bottom of the page, you'll find they're very complimentary about the way in which AWS has helped them meet their DR obligations and do so in a very, very efficient way. They estimate that it was 80% cheaper to build their recovery environment on AWS than it would have been had they done that in a traditional environment. We have Galata Chemicals, a chemical company also operating in the United United States who use AWS extensively for DR, and they cite scalability and flexibility, and also the simple nature of the services as being sort of key drivers for that. So they're using AWS for DR for their Oracle applications portfolio, so a traditional enterprise app supported by a DR environment on AWS. And Shaw Media, these guys are a large media company operating in Canada, and once again they're pointing to the financial benefits of running those DR services on AWS, saying it allowed them to implement their DR recovery strategy at a fraction of the cost of a traditional solution. So cost is definitely a factor, but also simplicity and flexibility are some of the other drivers here. And in your case, you might be able to reduce your cost quite significantly if you move your DR environments onto AWS, or build your DR environments on AWS rather than building them on traditional infrastructure. You might be able to eliminate a significant amount of your on-premises physical equipment, some of which is maybe regarded as legacy equipment, such as tape. And we talk there about removing aging technologies, that you can strip out tape, those costly and complex enterprise storage arrays that you might be running in your own data center. You can take those out and replace them with gateways or other technologies that might help you minimize your costs. And lastly, you can completely eliminate the need to run a second site in a lot of cases. So have a small environment on AWS ready to receive your data, and that can eliminate the need for you to run a second site in a traditional disaster recovery center or in a traditional disaster recovery service provider that you might use today. So 4 areas of benefit that you might be able to derive. And just some terminology that's important to clear up. So we're here talking about DR, but there's a couple of linked topics. One of them is backup. So this idea that you should make sure that your data is protected and safe, and that you can recover that data if you need to in the event of an operator error or system failure. And high availability. So this idea that you can keep your applications running 24/7. These different topic areas are not separate topic areas. They're all interlinked. I think it's important for organizations to take a look at their applications and decide what they have that needs to fail over and what does not, and determine which applications that you might have could be more important than others. Some other important terminology that you need to be aware of when developing a DR plan is the RTO, your recovery time objective. This talks to how quickly you need this asset, system, or data to be recovered. So this is how long it will take you to invoke your DR environment, follow your DR procedures, and recover your applications to production. And obviously you've got a sliding scale there of different times that you can aim towards, depending upon the criticality of your systems and the financial, reputation, or regulatory impact of those systems not being available to you. And then secondly, the RPO. So this is about how fresh the recovery must be for the asset. In other words, what's the level of synchronicity of your data replication, or the period between your data backups? How often are you going to take those, and therefore, in the event of a disaster, how much information or data might you lose? And those 2 things are questions that you need to ask your business before you can develop and deliver a DR strategy that meets their needs. So always have these conversations up front. And assets will sit on a spectrum of complexity. So you're going to have different application assets within your organization, different services, and you may consider the criticality of those services as sitting on this continuum that you can see here. So you may rebuild when required from offsite backup. You may look to run a hot configuration with auto failover. And as I said previously, the financial, regulatory, and reputational impacts of outages or of system loss will determine where each of your systems sits on that continuum. You may decide that your month-end or weekend reporting systems can quite happily have a 24-hour or 36-hour recovery time objective. You may decide that your customer-facing transactional applications, which are the real revenue generators for your organization, need to run in a hot configuration with auto failover, so in a high availability configuration. You need to determine for each one of your apps whereabouts on the continuum you're going to be. This is a traditional model. So a traditional model would be you would have a primary site, and in that primary site you would locate all of the infrastructure and software that's required to run your applications and to provide the support environment for those applications. In your secondary site, traditionally, you would have mirrored that. You would have built out that secondary site with the same stack of infrastructure that you would have in your primary. And the beauty of AWS is that you can dramatically reduce the amount of infrastructure that you have in that secondary site until you need to invoke DR. So your secondary site costs can be lowered quite significantly. And we'll talk about a couple of different architectural constructs that you can adopt in order to accept data into your AWS recovery site and manage the recovery process. Of course, AWS is global, so depending on where you happen to be located around the world, there'll be an AWS region close to you in your geography that you can use as the target for your data replication and for protection of your information. And by using the right region, the right AWS region, you can make sure that your compliance and data sovereignty requirements are met. So for example, if you're operating in the EU and storing PII, personal identifiable information in your systems, it's very likely that you'll want to use the island, the EU West 1 region as the target for your replication and do your systems recovery there, and then none of your PII will be moved outside the EU and you won't need to notify your customers as such. Similarly, in other regions around the world, take advantage of that same model. And the AWS regions themselves and the services that we provide, they're built to very rigorous security standards. You can find a whole lot more information about security at AWS if you visit the URL that you can see at the bottom of this slide, http awsamazon.com/security. You'll find a great deal of detail there about how we secure the AWS environment and also what responsibilities AWS retains and what responsibilities you have to shoulder as a user of the services. So if you're going to move PII or other data which is subject to regulatory or privacy oversight into Amazon, please make sure that you've reviewed that and you're familiar with the controls that are described there. So let's move on now and take a look at AWS services that can be employed for DR. And we're not going to cover everything here in exhaustive detail, but just by way of an example. Firstly, object storage and transfer services. So the simple storage service, the object store, highly durable object store service that AWS provides. This can be used as a target for data backup and replication. It can interface with various appliances which can present localized storage to you on your premises, but be backed off into Amazon S3 for durable storage in a region of your choosing. We also have a service called import-export, which is as simple as allowing you to send storage media to an AWS region, where we will then load that data into S3 for you and make it accessible to your instances. So if you have very large data sets that you want to periodically send to AWS in order to keep that large data set in a secondary location and keep it in sync, you can use the import-export service for that. And we have the storage gateway, which we're going to talk about in some detail later in the session today, which is one example of an appliance that will give you localized storage on your premises while protecting the information in that storage back onto Amazon S3. There's a variety of network services that can be used to connect your data center or network to AWS. AWS Direct Connect can offer you a 1 or 10 gigabit interconnect, a private interconnect, which will allow you to take your traffic off the internet and therefore potentially assure more consistent performance. And also you can take advantage of lower latency network services if you use that. Many large customers opt to use Direct Connect as a mechanism for connecting their production data centers to the AWS cloud. Within the cloud, you can partition up your AWS resources in a VPC or a set of VPCs, and within those virtual private clouds, you can take your own addressing scheme, your own subnet layout, and build the network and topology that's required for you to support your applications. So that's also a very important service. And we'll look at an example towards the end of the presentation today, which talks in detail about how one specific customer uses the Amazon VPC in order to build out their DR environment. And if you do have publicly facing services, then the Amazon Route 53 DNS service, of course, is a way for those services to be resolved and accessed by your customers on the internet. And then there are foundation services. So Amazon EC2, the Elastic Compute Cloud, the relational database service that you might use for running Oracle, Microsoft SQL, MySQL or Postgres databases on Amazon Web Services, and the Elastic Block Store, where you may create and attach block device volumes to your compute nodes and use those block device volumes to store your data. There's actually a variety of different EBS options available to you now which have differing performance characteristics. The PIOps volume type is quite interesting because you can, this is provisioned IOPS, build your volumes with low performance levels, and as and when you need to invoke DR, you can crank up the number of IOPS that are available to you. Your bill will increase in response to that, but so will the performance of your application. So there are some options there for tuning storage to more accurately meet your workload needs also. Okay, and this storage is actually ideal for DR for a couple of reasons. The first is you only pay with S3 for what you consume, so it's true capacity-based billing. If you have a small amount of data in the system, you'll only be paying a tiny amount for that, and as you scale up with more backups or more recovery data, your cost will scale. In any event, you'll benefit from that 11 nines of durability, and you'll also benefit from having your information retained within the region that you've placed it into. So there's no copying of data or information between regions by Amazon Web Services. The region that you place it in will be the region that your information is stored within. And then on the other side of the chart here, you can see the Elastic Block Store. So the volumes that you attach to your EC2 instances, those are available for you to use and place data on, quite obviously. And that will enable you to create file systems or use raw devices that you might use for storing operating systems and application data. You can also snapshot and clone these EBS volumes. And that can be a mechanism for creating instances that match the characteristics of systems that you might have on your own premises. So we'll talk about techniques for doing that in a few minutes. Connections to AWS we touched upon very briefly. So Direct Connect, this is a dedicated connection between your infrastructure, that's either a data center, a network, or a point of presence that you have, and the AWS data centers or regions. And you can extend your network infrastructure and VLANs into AWS over those Direct Connect services. We offer a connection location, for example, here in the UK in Docklands, where you could bring your network and connect it to a Direct Connect point of presence. We also work with a wide variety of Direct Connect partners that can bring high bandwidth services directly to your site or data center or some other point on your network and connect those back into AWS for you. So check out the Direct Connect partner section of the website if you want to know more about who those guys are and where they operate. You can build a VPN connection over the internet. So this is an IPsec VPN controlled, as all AWS services are, via the API console command line. So you can create or destroy your VPN endpoints using those different tools. Put VPN credentials on your own site, on your own VPN concentrator or termination device, and then build your tunnel over to AWS and use that to secure your data as it travels across the internet. And then inside the AWS Cloud, as we've already said, you can section up your network using the VPC, defining the virtual network that meets your needs with complete control over how it's laid out, and launching your AWS resources in those subnets of your choosing. Some common architectures that customers will use for DR. Excuse me. So there's 4 patterns here. We're going to focus on 2 of these today. We're going to focus on backup and restore and pilot light. And in the references that I will show you at the end of the session today, you can find out more about the other 2 patterns that are described here very briefly. So warm standby and the multi-site solution in AWS and on premises. So let's start by looking at backup and restore for today. Now, this is a very simple way to get started with AWS, a very, very low technical barrier to entry. And you can focus on incorporating cloud into your DR strategy without having to deal with complex technical issues that might be related to, for example, having those hot systems that are distributed across sites. You can access very high levels of data durability on Amazon S3, as we've already said, and the cost of storing snapshots in S3 is very low. And you can have archiving possibilities beyond tape by using a service called Glacier that we'll touch upon in a few moments. Basically what you do here is take a backup of your current systems and store those backups within S3. And over the long term, you can tear down or archive those backups into Glacier. And there's a wide variety of different backup tools, different backup software, which is supported by, or which supports the Amazon S3 API. So if you're using Commvault or Symantec or some EMC backup tools, these tools can write into Amazon S3 as though it were a storage device, and your information will be stored off your premises automatically, of course, but you can manage it using the familiar interface that you might be used to within one of those commercial backup products. And it's important as part of this, implementing this kind of strategy, to detail precisely how you will restore from backup or recover from archive. So this is probably the most important piece of information I'll give to you, that these backup processes need to be complemented by thoroughly tested and operationalized recovery processes. So part of your DR planning ought to be to work out precisely how you're going to execute those recovery operations. Glacier is a tool that you can use for long-term durable archive. So the same durability level as Amazon S3, but it's more cost-effective for long-term storage. You pay when you access data. So in the DR scenario, that would only be during the invocation process where you needed to retrieve your data from Glacier. This is how the service works with lifecycle management. So you're placing objects into S3. Those objects can expire and be deleted under a policy, or you can implement a transition policy which will, rather than expiring and deleting those objects, it will tear them down into Glacier, and then you will need to issue a restoration request to bring those objects back from Glacier. That restoration request will be executed in 3 to 5 hours, so therefore, by definition, it's only suitable in scenarios where you've determined that your recovery time objective is greater than 3 to 5 hours, and then your object will be held in S3 RRS, and you can access it with your backup tool to recover your data. So that 3 to 5 hour retrieval time clearly assumes that you won't access your data often, and there is actually a charge for accessing data beyond a certain threshold. So it's ideal for low-cost, long-term archive where you only have a very infrequent need to access data. This is how it works in practice. So you push your backups into AWS. In this case, you can see a connection from that database server in that co-location data center, which might be using something like Oracle Recovery Manager, RMAN, which supports S3, to back up that database into S3, and also to maintain within S3 snapshots of the system images that would be used to recover systems in the event of an invocation process being required. And then in the event that that co-location data center is lost, you would start your instances from those AMIs that you've got stored, those Amazon machine images that hold the golden images for those system components, and you would recover your data back into that database server, once again using RMAN. You'd then be running in AWS rather than in your co-location facility. Let's move on and talk about the storage gateway. So this is a slightly unusual AWS product or service in the sense that you install it on your own premises. Okay, so the storage gateway is installed on your premises, and it synchronizes local volumes to Amazon S3. You create local volumes on that storage gateway, which are made available to you using the iSCSI interface. So you would mount the volumes that are made available on your storage gateway on the hosts using iSCSI, an iSCSI initiator. And then those volumes, they would be snapshotted, compressed, and stored in Amazon S3 in a way which you configured with your storage gateway. Incidentally, this storage gateway is not a physical product. It is a virtual machine which runs either on VMware or Hyper-V infrastructure, presents those iSCSI volumes as you configure them, and then backs those volumes off into Amazon S3 in order to protect them. And in the event that your volumes on your local site might be lost in any sort of disaster scenario, you can pull those snapshots back from S3 and restore your local volumes to service. So it's a mechanism for effecting mirroring of your data from your own premises to Amazon's AWS Cloud. Alternatively, you could pull those volumes from S3 and create a cloud instance within AWS backed by that volume. So this would be in a disaster scenario where your VMware infrastructure, your storage gateway, potentially your server infrastructure at your own premises was no longer available. you could use the snapshots that you created with that storage gateway to create or rehydrate EC2 instances within AWS and start running your workloads in AWS rather than on your own premises in that corporate data center. There's two different options here. So one of them is called gateway stored volumes. These are up to 1 terabyte in size, and these are the volumes that are asynchronously backed up, asynchronously mirrored to Amazon S3. Okay, so you can use EBS snapshots on those. Your data is stored locally. All of your data is stored locally within the storage gateway as well. So you're going to get good performance for all of your 1 terabyte volume. The other option is something called gateway cache volume. In this particular deployment model, only your recently read data is cached within your storage gateway, and infrequently accessed data will be archived up into S3. So if you hit an object or a file which has not been accessed recently, that will be pulled back over the network, stored in the cache on the storage gateway and made available to you over the high-SCSI local interface. And here you can have much larger volumes, but obviously you've got a little bit more latency if you're accessing files which might be infrequently accessed files outside the cache volume which is held locally. This is how the model looks. So here you're looking at corporate data centers with storage appliances. Now the storage appliance is connected over that secure connection back to S3. And the reason that we're saying storage appliances here is because the Amazon storage gateway is only one option. You can also use third-party storage appliances. There's a wide variety of different options that you've got there. People like Riverbed, Twin Strata, and a host of other providers that create these storage appliances which will back the AWS Cloud into your premises and present local storage that you can use either for running production systems or as a target for backups with synchronization back into AWS S3 to make sure that your data is protected in that high durability environment. So there's many, many vendors that provide those storage appliances, and you can find a whole lot more detail about that if you take a look in the partner section of the AWS website. Lots and lots of those vendors are listed there. Okay, so you're not limited to the AWS gateway. If you want to have a different product there, you can certainly insert and use a different product, and they've all got their own feature sets, of course. You mentioned earlier this idea of using RDS and Oracle RMAN. So in this particular recovery scenario, what you're talking about is running Oracle on your own premises in that corporate data center and using Oracle RMAN as a mechanism for backing that up directly to S3. And then in the recovery scenario, recovering that back into an RDS instance, running in AWS and recovering application server instances, which would also be running in AWS. So this would be a recovery scenario for recovering an Oracle environment into AWS in a disaster. And there's a lot more documentation about this kind of approach within the architecture resources that I'm going to show you towards the end of today's session. Okay, so that's all about backup and restore. Let's take a look now at the pattern for the pilot line. This is quite interesting. So we're talking here is having a minimal environment running in AWS, which represents this pilot light environment, just enough to receive the replica of your core databases. You build the resources around that data set that you would need in order to invoke DR, but you don't leave them running, you leave them in a stop state. And what that means is you can scale the resources that you have in AWS in response to a DR event. So this would enable you basically to turn up the amount of AWS capacity that you have if you need to invoke DR, but in normal circumstances, your costs would be dramatically reduced because you would only run the AWS resources that are required to receive that stream of incoming data, that replica. And you switch over to that system in AWS in the event of having to run through your invocation. You can see an example of this here where you've got that database server running in AWS, which you can see in the center of the slide here. You've got that database synchronization taking place. There are a number of EBS volumes attached to that database server that you can see here. And those EBS volumes are periodically snapshotted into S3 in order to protect them. And then you have a couple of stopped instances for your web and application servers here, which in normal circumstances are not running, but in the event that you need to invoke DR, you would start those instances, potentially scaling up the database server and or scaling up the number of PIOps on your EBS volumes back here, and creating an environment that's capable of satisfying production demand for your application, whilst being in the situation when you've not invoked DR, that your costs are dramatically lowered. So that's a good model for complex applications where you don't want to carry the full cost of operating a second environment for those applications when you're not having to invoke your DR environment. Let's move on now and take a look at a customer example that's putting many of these concepts into practice. This is an organisation called Haven Power. So they're an energy retailer here in the UK that focus on providing energy to commercial organisations, so mid-sized businesses essentially. And they're operating a DR site for their business inside Amazon's EU region. So they've got PII and other privacy sensitive data, so they're storing that inside the EU West region in Ireland. They're running all that in a virtual private cloud inside a VPC. And they're using that to provide DR provision for applications which have dependencies on Oracle and SQL server databases, so traditional enterprise apps. They also have some of what I would call services, so IT services like Active Directory and Windows file shares. They make those available in their DR environment as well, so they have the scaffolding that might be required for desktop recovery or for supporting their enterprise apps with authentication services available. And their architecture looks a little bit like this. So here you're looking at their VPC layout with the different subnets, and we'll just step through the different components. So the first thing is dual root connectivity, because this is a really important service for Haven. They're operating in a regulated environment under the overwatch of a regulator here in the UK called Ofgem, which is the power regulator and energy market regulator here in the UK. They're also clearly running billing and other revenue generating applications which they want to have available in this DR environment, and they are blending a combination of direct connects together with internet VPNs in order to make sure that they have cost optimized and good performance dual root connectivity into this environment in the event that they need to access these applications remotely during invocation. They have those services that I mentioned, the Active Directory and file services that you can see here. So Active Directory made available within a separate VPC for security reasons, partitioned away from their other applications and services. They have Bastion hosts, once again, to enforce that security posture, again in a separate VPC. So administrators and systems operations people would connect in via those bastions and then hop from there to the rest of the infrastructure with strong security controls around the bastion to ensure that no unauthorized access is possible. They have database replication, once again feeding into a different VPC, receiving data from those Oracle and Microsoft SQL databases, and maintaining a replica of those data sets in this recovery environment. They have those application images available to them so they can start up the application environments that they require, and they also have remote desktop environments. So if they lose one of those data centers, which is co-located, their own data centers, which is co-located with some of their office staff, those office staff can work remotely using those remote desktops and still access the applications that they need to access in order to ensure that their business continues to function. And there's much more detail about this particular reference case available in the case studies section of the AWS website. So where can you go to learn more about DR on AWS? The first thing to say is these architecture diagrams that I've been showing you today, and there's another example of one here. There's a architecture center available to you that you can see here, awsamazon.com/architecture. If you take a look at that, you'll find not only disaster recovery and backup patterns, but also around 40 or so patterns that reflect best practices for common application deployments on AWS. So definitely take a look at that architecture center as a follow-up action. It's a very, very useful resource, not just for DR, but for any substantive application deployment on AWS. We also have a disaster recovery solutions section on the AWS website that you can see at the top of the page here. And if you take a look at that, you'll find many of the case studies that I've talked about today detailed in much more detail there, and also some more descriptions as to how you can apply common AWS services into this particular use case. And there are a couple of white papers as well on disaster recovery, and backup and recovery. So if you take a look at those, again, you'll find very, very detailed descriptions of how you can implement DR, best practices for implementing DR on AWS, and leverage that best practice instead of reinventing the wheel yourself. That's one of the best pieces of advice I would give to you, really, is don't reinvent architectures and practices that AWS has already developed and refined in conjunction with some of the other customers that we have that are doing similar things on AWS today. So very quickly to summarize, cloud can make backup and recovery easy through the low cost and durable storage that's available, and through those integrations with those common data backup and recovery products that you're probably already using today. You can get started at very low cost, and you can run those pilot-like environments at very low cost also. And of course, if you want to test or try invocation processes, if those don't work out for you, of course, there's no commitment to maintain service with AWS. You just pay as you go. So you can trial and test different recovery or invocation scenarios, very little risk. There's obviously scalability for the cloud to accommodate all of your data. I've not really talked about non-DR, non-backup and recovery use cases today, but just by way of an example, we've got one customer in the medical imaging field that is uploading over a petabyte of data a month to AWS. That's a petabyte of new data every month to AWS. So no matter how big you are, we have the scalability to handle your workload and to handle your data replication needs. And lastly, with AWS, the self-service nature of the services means that you retain visibility and control of your information. You can remove information as you see fit. You can build a security policy and posture that will meet your compliance and security needs. And you can use the AWS Amazon.com/security resource center to find out more about precisely how you can do that, what tools we provide, and how you can engage your information security teams with AWS to make sure they're confident about your move to the AWS cloud. Okay, where you can go to learn more. So there's a comprehensive training and certification program available from AWS. There's some self-paced labs, several of which give you an opportunity to try foundation AWS technologies for free. So check those out at the self-paced lab link that you can see there. There is a set of classroom training which is available for you, delivered by AWS and also by selected training partners in different geographies. So if you're interested in that, architecture, systems operations, or development on AWS, then visit awsamazon.com/training. You can find more detail about that. And we match those training opportunities now with certifications. And again, there's another URL there that will explain to you what your certification options are for AWS, how you can learn and validate your AWS knowledge through that certification program. We just announced a couple of weeks ago, practice exams are made available as well for certification. So you can, for $20, check your AWS knowledge with a practice exam. And if you're comfortable and past that, you can move on to certification with a pretty secure expectation that you'll do well in the final exam. Here's some social media links that you can go to learn more about AWS. So if you follow us at AWS_UKI, you can stay up to date with our webinar program here in Europe in the English language on that link, and also with other events and AWS news here in the UK and Ireland. And if you want to stay up to date, up to the second up to date with AWS service and feature launches and global AWS events, then follow us at AWS Cloud, also on Twitter. Of course, you can find me at ENM, which you can see there. So we're going to take a look at a few questions now. I'm just going to minimize or reduce down the size of this presentation window and bring the questions in, just so I can take a look at what questions have. If you've got any more questions, guys, please do submit them. We don't have a lot of questions today, unfortunately, but we'll try and answer what we have. So the first question is, does AWS have any S3 snapshotting tools with DR? It gives you a UI to control snapshots and DR. There's obviously the storage gateway we've touched upon a little bit today, and there is a UI for the storage gateway which would allow you to control the EBS snapshotting and also the replication characteristics of the storage gateway. But you're right, there are also a large number of third-party tools available. So we'd encourage you to look to both third-party and AWS tools and try to determine which tool is most appropriate for you. There's a question here about how is storage gateway licensed? Do you pay a cost for its use above the S3 Glacier storage? You do pay a small incremental charge for its use above the cost of S3 and Glacier, yes. There's a storage gateway product detail page on the website that provides full details of the pricing, which I'll find and I'll get one of our solutions architects to you, Chris. Chris asked that question. And in fact, all the questions that have been asked here today will be answered in follow-up by our solutions architecture team. So we will come back to you on all these questions and write to you with a written response also in addition to the answers that I'm giving you here today. Can OS images with system-specific drivers or configuration stored on AWS compute platforms? I think the answer to that question is it depends precisely what the system-specific drivers and configurations are. One thing we do support is we support import-export from the VMware format. So if you're running your environment on VMware and you have VMware virtual machines, you can certainly port those virtual machines to AWS and build a recovery environment. We also have a tool now which is integrated with VMware vCenter, which allows you to control your AWS environment from within the vCenter portal and to move VMware virtual machines from that VMware environment directly into AWS for recovery purposes. So a process might look something like this, that you would convert your machines to VMware instances, VMware VMs using a P2V tool. There are quite a number of those available to you, as I'm sure you know. And then use those once you've got those images inside your VMware environment, then port those into AWS using the tool I've just described to you. Another question here from Stephen, which says, can customers specify which up in? Yes, they can. As I said during the presentation, you choose which AWS region you're going to work with. At the moment, in the Europe, Middle East and Africa region, we have the single region in Ireland within the EU. But if you're operating in Asia, we have Singapore, Japan and Sydney. If you're operating in South America, we have Sao Paulo, we have Beijing, and we have several locations in North America as well. So you can specify which one of those regions you want to work with, and nobody at AWS will move your data outside of that region. And of course, we'd also encourage you to encrypt your data as well to protect it whilst it's stored with AWS. So use encryption at every point that you can, just to make sure that your data is as protected as it can be. Okay, we've got several other questions, but I think the rest of the questions we're probably going to come back to with written answers. So I'd just like to thank you for your attendance today, for joining us on this new platform for today's webinar. I hope the experience has been good for you. We did have a couple of people that mentioned audio issues, but we've got a large number of people on the line that didn't raise any concerns about audio. So I think maybe there's a few connectivity issues with the IP voice that might be impacting that, but certainly we'll look into it. Don't forget to join us later in the month for the DynamoDB masterclass that we're going to run. And keep an eye out on your email for future Journey Through the Cloud webinars. We have the rest of our program to complete this year, so look out for that. Thanks for joining us today. Please provide us with feedback either on Twitter or in the questions. Thank you. Bye-bye.